Okay, so we're doing the S1 International Edexcel 2015 paper. The first question is a cumulative distribution function question. Cumulative distribution function is basically defined as this. Fx is a probability of the value of x being less than or equal to that value x. So in other words, F4 would be the probability that x is equal to 4 plus the probability that x equals to 3 plus the probability that x equals to 2 plus the probability that x equals to 1. And F3 would be just 3 of these without this one here, and so on. And well, it shouldn't be difficult to see here that F4 must be equal to 1 because one of these is going to happen. So F4 equals to 1. So that gives me 1 is equal to k times 4 squared. So k equals to 1 over 16. Okay. Now it says find the probability distribution. Well, that just means put the numbers into a table. So the possible numbers are 1, 2, 3, and 4. And we have p x equals x. And now we can build up from the top or the bottom here. Now, as I said, it's cumulative, but so in other words, f of x is equal to the probability that big X is less than or equal to little x. So f of 1 is equal to the probability that x is less than or equal to 1. Now in this context, that's the same as the probability of it being equal to 1, because it can't be any less than 1. But we know that f1, because if I write my fx now, we know that the function for it is 1 over 16x squared. So f1 is equal to 1 over 16 times 1 squared. So that equals to 1 over 16. So we have 1 over 16 there. Now f2, let me rub some of this out now to make some space. f2 is equal to probability that x equals to 2 plus the probability that x equals to 1. Right, well f2 is equal to 1 over 16 times 2 squared. So the probability that x equals to 2, if we put that there, but we already know the probability that x equals to 1, which is 1 over 16. So the probability that x equals to 2, this is 4 over 16. This is 1 over 16, so the difference between those is 3 over 16. And we can do the same we can work out f3 must be equal to probability that x is less than or equal to 2 plus the probability that x equals to 3. Well, we know that f3, putting 3 into here, is 9 over 16. We've already worked out this one, okay, because that's the answer to px equals to 2. That's 4 over 16. I could have written, I suppose I could equally have written f2 here. Same thing. So f2, and we've worked out f2 before, that's equal to 4 over 16 plus px equals to 3. So that gives us that is the difference between those two is 5 over 16. Now of course all of these are going to add up to 1, so we probably don't need to make too much of a fuss of the last one to work out 7 over 16 there. Okay. So that's that question done. Let's have a look at question 2. There are some formulae that you are given in the formula book. We're normally using these side of the formula and this, and this. because it's a regression question. And there's also some coding, which I think will come later on in this bit of the question here. Anyway, Sxy, as given in the formula book, is equal to sigma xy minus sigma x, sigma y, the sum of them individually, divided by n. And we're told there's 20 here. So that equals to, we're given sigma xy, that's 1474.1. We're given sigma x, that's 441.5. We're given sigma y, which is 59.8. And we know the total number of numbers is 20. So that gives me the number 154.015 or 154 to three significant figures. Okay. Sxx, we say it's given in the formula book, is equal to sigma x squared take away sigma x squared, the sum of them squared, divided by n, and we're given sigma x squared here, so that's 11261.25. We're given sigma x here, so that's 441.5 squared, all divided by 20. And that comes to 1515.1375, which is 1520 to 3SF. Okay, that's the part A done. Then it says find the least square regression line in the form y equals ax plus b. Okay, a plus bx, should I say? Well, there is a formula to work out these things, and this is to work out b. So b is sxy over sxx. Which is my 154.015 divided by the 1515.1375 using the unrounded answers, and that comes to 0.101-65084. Now we're not going to write that in our regression line, but I would advise storing this in the calculator so that because we're going to use that for the next line. Okay, now there is a formula for working out B, which is for working out A, which is here. I tend to kind of just use common sense though, but you can use the formula there. We know that the equation is y equals a plus bx. Well, the mean point has to go through that line, so wherever the mean is has to go through our line of best fit. So we can just put x bar and y bar in our line of best fit and rearrange. So we have a is equal to y bar minus b x bar. It is in the formula book if you prefer, but sometimes it's just as well to think about why it's equal to that. Anyway, so we've got a equals to y bar minus b x bar. So we do need to work out y bar and x bar. Okay, let's just go back briefly. Y bar. Well, we've got y here. So y bar is equal to sigma y over n. So that's 59.8 over 20. okay, which is equal to 2.99. Okay, and x bar is sigma x over n, and so that's 441.5 over 20. So that's 22.075. Okay. Now, what we can do then is work out the using the formula what A is, using all this, because we now know everything in this formula. We've got B here, and we've got y bar and x bar there as well. So A is equal to y bar 2.99, take away B, which is that 0.1, and do use the, don't have to write it all out in your formula, but when you write it out, but do use this complete answer, or at least significant, enough significant figures, times this number here, x bar, 22.075. So that gives me A equals to, and then that comes to 0.74660577. Now we don't want to really see that in our final line of best fit, so in our equation, our regression line, so that gives us y equals 0.746, so we'll round that to 3 significant figures, and we'll round the other one as well, 0.102, this one here. Okay, so that's our regression line. Okay, so it says our least square regression line is of this form, v equals to c plus ds. Now this is where the coding formula bit comes in, because we've got our coding formula at the top here. So we're just going to put x and y into our coding formula, so it's not going to be particularly difficult. I probably ought to say which questions I'm doing here. C, and this was A, and this was B. Okay, so we've got V over, what is it? V over 100,000 equals to 0.746 plus 0.102 times s minus 50 over 10. Okay, so first of all I'm going to do, let me just get question 3 out of the way. I obviously need more space. So I'm going to times through by this 100,000 first of all. So we get V is equal to this number here times 100,000, which is equal to 746, or we could use our original number from here, 746,05.77 plus, and we could use our original number here, that times 100,000 would be equal to 10,165.084. I'd say probably going a bit over the top with our number of figures here. Divide by times by s minus 50 divided by 10. So that gives me V is equal to 74605.77 plus, this now can be divided by 10 here, so that's 1016.084 times S minus 50. Now let's multiply that out. V is equal to 74605.77 plus 1016.084S minus 50 times that. So that's 50 times 1016.0845. So that's 50804.225. So then if I find a difference between those two, I get V is equal to, I just noticed a slip here. It is, I'm not using the memory on my calculator when I should be, so just let that be a warning to us. So it's 10165084. So that makes that number below 1016.5084, and this number here is then therefore equal to 50 times that, which is 50825.42. And then combining the, oh, I've got an S there I need. Look like a 5, but it's an S. So then that makes it, when I combine all those two together, I will get 23780.34997 plus 1016.50845S. A little bit over the top with the number of significant figures. I'd probably round that at this stage now. So V is equal to 23700 plus 102S. The original question says, so that to three significant figures 102S, so as with 1020S, of course. Okay, so D equals to, so you might as well, just in case they write what the values are, D is 1020 because that's the coefficient of S, and the other symbol is C. C is equal to 23700. Okay, so that's that question done. We're not done with this question yet though. Let's have a look at the rest of it. Let me tidy up so we can have a look back at the other bits. So part D says estimate the value of floor, which is 130 meters squared. I'm going to use the more precise measurements here just to avoid any difficulty with rounding from here. So we can always round it at the end. That's probably the best way to go. So estimate the value of the house. So the value is equal to this 23780.34 blah 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 plus 1016.50 dot dot dot, I think that's enough, times by 120. Okay, and 130 should I say, and that gives us the value, for V of 155926 with a lot of other stuff. If we want to give three significant figures, it's quite a good idea to do that always. So 3SF. There we go. Now these questions, interpret the value of D. Right, let's have a look back at the data here. We've been doing a lot of, students often like doing all the calculations and stuff, and they don't like the actual thinking about the data and what it represents and interpreting it. So let's have a look back at what the data was about. I haven't actually mentioned it yet. Paul believes there is a relationship between the value and the floor size of a house. he takes a random sample of 20 houses and records the value. And so here, well, we can see, of course, that there is a relationship. It's a linear relationship here. In this 1020 here. And it tells us this number here tells us the extra amount that each 1 meter square in floor size will increase by. So we need to mention that number. So we would say something like £1020 is the increase in the value of a house, in the value of the house, in the whatever. For every 1 meter squared extra floor space. It's a gradient, but that's not an interpretation to say it's a gradient. Basically what we're saying is that as it goes up by 1 meter squared, the value goes up by that amount, 1020, and that. So it's a gradient. So I often think, well, draw a little graph of it here. Put the 1 there, that's the thing that you're increasing, the extra bit. In this case, it's floor space. How much does the value of the house go up? Mention the number in your interpretation and say what it means. So that will get you your few marks. And then it says, Paul wants to increase the value of his house. He decides to add an extension to increase the floor size by 31 meters squared. Estimate the increase in value of Paul's house after the additional extension. Right, so the increase in value, remember it's not the actual, we don't have to use this thing, we're just using this 1020 now. So all we have to do is just do the 31 times this increase here, which is this number here, 31 times 1020, because for every 1 meter squared extra, you get this amount extra in value. So if we work that out to 3 significant figures, that comes to 3 1 600 to 3 significant figures when you add those together. Okay. If I use the original rather than the 1020, if I use this number. Okay, so that's the answer to that one. Let's have a look at question 3. Okay, question 3 is a probability question. It may not look like one initially, but it certainly is. It gives a company a kind of breakdown of 80 employees in a company by gender and by time employed. So if the number that female is easy to work out. The probability of female, well, all those add up to 30. So that's 30 over 90, or a third. So that's no problem for part A. That's easy bonus mark. Then it says, given the administrator has been employed by a company for more than 5 years, find the probability that the administrator is male. So we can use a formula for this, but what we can say is if they're employed for more than 4 years, that's actually all of these together. Okay, so we can use a formula for this. Let's do it that way rather than just try and do it by common sense. So we've got the probability that they're male, given that they're less than 4 years old, 4 years employed. 4 years old is unlikely for a company employee. So given that they're less than 4 years employed, well, actually looking at it, rather than use a formula, I'm looking at it and say, actually, there's only 25 of these people that are employed for less than 4 years, of which 16 of them are male. So we can just do 16 over 25. We can use a formula for it, in which case we just work out what the probability of both of these occurring is, which would be 16 over 90. I'll just write it up there. If you do the probability of both of them occurring, divide by the probability of this of x is less than 15, which would be 25 over 90, and that will get us, using the formula, into the given result. But I am going to just use reduced sample space, kind of a common sense approach. It did seem like a better way to go on reflection. Okay, part C says, given that the administrator has been employed by the company for less than 10 years, find the probability that their administrator is a male. So again, I'm going to, this time I perhaps will use the formula, so because otherwise we might mess up. So we're being asked for the probability that they're male, given that they're less than 10 years employed. That equals to the probability both, so probability that they're male and they're less than 10 years employed, divided by the probability that they're less than 10 years employed. Well, the probability that they're both these, that they're both less than 10 years employed and male, is a combination of those two out of, so that's 36 out of 90, divided by the probability of them being less than 10 years employed, which is the total of these out of 90. So that's 20, but that's 36, 60, 59 out of 90. And the 90 is just a common factor that we can cancel. So there we go, 36 over 59. Okay. And then state with a reason whether or not selecting a male is independent of the event selecting an administrator who has been employed for less than 4 years. So we're going to have to work out quite a bit of stuff here, because we need to work out probability that they're male. Well, we've got the probability they're female is 30 out of 90, but it's 60 out of 90. So the probability that they're male is 60 out of 90. The probability that they're less than 4 years employed is equal to, that's those two, which is 25 out of 90. The probability that they're both is equal to, now the probability that they're both that is equal to 16 out of 90. Now PM times P, if we can show that this is, these two multiplied is equal to this, then they're independent. So let's see what PM times P less than 4 years equals, that's equal to 60 over 90 times 25 over 90. Okay, and that equals to 5 over 27. Now these two figures are not equal, which is not equal to PM less than intersects in 4 years. And so because they're not equal, that means they're not independent. Okay, been doing 30 minutes, let's do one more, and I think the others will have to wait till another day. So let's look at the next question. Okay, so it's a probability question. You might be tempted to do tree diagrams here, but I'm going to try and do it without, because we should be able to really. But the first bit is basically to do with red and blue beads, and we've got the beads being selected and replaced. So it says something about it being replaced. So the probability that both are blue, because they're independent of each other, there's 20 beads altogether, so it's 1 over 20 times 1 over 20, which is 1 over 400. Okay, part B, exactly one bead is red. Well, we've got to bear in mind there, as I say, we could do a tree diagram like this. Red, blue, and then red, blue, and red, blue. But really, all we really need is the two outcomes, red, blue, or blue, red. So that's basically equal to, so the probability, so we've got one of those, so it's equal to 2 times the probability of selecting a red one, which is 19 over 20, okay, times by the probability of getting a blue one, which is 1 out of 20, which is 19 out of 200. Okay, so that's not too bad. Let's have a look at the next question, C. In another bag, there are 9 beads, 4 are green and the rest are yellow. Linda selects 3 beads but without replacement this time. Find the probability that 2 of these beads are yellow and 1 is green. Again, feel free to do a tree diagram if you want, that type of thing. Red, blue, green, red, blue, green, red, blue, green. But I'm kind of aware that really, although there's plenty of time, if you know what you're doing with the exam, any time that can be saved just by thinking about it is probably a good idea. So I'm going to do it without a tree diagram. Find the probability to we've got 3 beds being selected from a bag and there's no replacement. That's key. Now we've got we want to find the probability that 2 of these beads are yellow and 1 is green. Now the thing is, that could be red, blue, it can't be red, can it? Green, 2 are yellow, so we could have yellow, yellow, green, yellow, green, yellow, or green, yellow, yellow. Now if we wanted to find the probability of each of this one, the probability of getting a yellow one is equal to 5 out of 9. But then, of course, if we've selected a yellow one, because we're not replacing this time, we'll then have 4 yellow ones left. So that'll be times 4 out of 8. And then to select the other one that's green, 4 of them are green, so that will be 4 out of 7. Okay, now I'm going to work each of these individually out just to kind of demonstrate the point, but in fact hopefully you'll see this quicker way. So the yellow one, this time again it's 5 out of 9, times by 4 out of 8 because that's the probability of getting a green, because there's still 4 greens left out of 8. But now there's 4 yellows left, but there's 7. Those were exactly the same. Let's make a bit more room for this. So then we've got green, yellow, yellow is equal to, this one is equal to, so green is 4 out of 9. We've selected the green one. Then we've still got 5 yellow ones left, so that's 5 out of 8. And now we've got 4 yellow ones left, that's 4 out of 7. Now what you'll notice is, look at the top, we've got a 5 times a 4 times a 4, a 5 times a 4 times a 4, and a 4 times a 5 times a 4. And then on the bottom it's all the same. They're all the same. Each one of these is the same. So instead of, and it will always be like that with these types of questions. So we can actually find the probability of that we want is going to be the probability of, let's write 1 green, 2 yellow, is going to be equal to 3 times 5 over 9 times 4 over 8 times 4 over 7. And that equals to 10 over 21. So finally, last one. Linda, another scenario, replaces all 3 beads, so we've still got the 9 beads, and then selects another 4 at random without replacement. Find the probability that at least one of them is green. In this type of situation, it's probably best to find a probability that they're all yellow. And then just do 1 minus, because that's every possibility except that they're all yellow. So if they're all yellow, again, how many yellow ones were there to start with? There were 5 yellow ones, so that's 5 out of 9. But then we've picked one of the yellow ones, so that's 4 out of 8 times 3 out of 7 times 2 out of 6. That will give us the probability that they're all yellow. So then the probability that at least one is green is equal to 1 minus that number. So that's equal to 121 out of 126. Okay, so that is that question done, and I think we'll leave the other questions. I think there's 4 more to on part 2.